So when we solve systems of equations by elimination, we are trying to eliminate a variable. Basically, we have two variables, x and y, and it makes it tricky to solve for a variable because we have two variables to solve for. So if we eliminate one of them, it makes things a lot easier. So for this first system of equations, which just means more than one equation, if we think about adding these up together, this is a big giant addition problem. If you do negative x plus x, since they're inverses or opposites of each other, those cancel. They add to 0x, which I'm not going to write. Then I can add my 1y and my negative 5y to get negative 4y equals, and I can add 5 and negative 9, and I get negative 4. Now I can just solve for y. Because I eliminated the x, I'm able to solve for y. And so y equals positive 1. Just like with substitution, once we have our answer of y equals 1, we can plug that back into the either equation that we want. So say I plug it in right here. I get negative x plus, I know that my y is 1, so plus 1 equals 5. And now I can solve for x. So minus 1 from both sides. Negative x equals 4. Divide both sides by negative 1, because that's a negative x, or you can just flip the sign, however you think of doing that. But divided by negative 1, and so I get x equals negative 4. So for the shortcut, if you know that when negative x equals 4, you could switch the sign. X is negative 4, if you don't want to do the math on that. Okay, so I got y is 1, x is negative 4, but with the system of equations, remember when we learned graphing, they intersect at one point, so I actually need to make this an ordered pair. That's my final solution to this system of equations. It will intersect at negative 4, 1. Here, in order to eliminate, if I make this my large addition problem like normal, and I start adding, I'd get 10x, or for the y's, I'd get 3y. I need the x's or the y's to cancel. So since the, let me get my pointer up. Since the 5x and the 5x are almost ready to cancel, if one of these were negative 5x, it would cancel. So I can make that happen. I can just change the sign of everything. So to make this negative, I'd also have to change the sign of the 2y, that's going to become negative, and change the sign of the 30, and that's going to become negative. And now I can go ahead and add. So 5 and negative 5x canceled. 1y minus 2y, or 1 plus negative 2y, gets me negative 1y, or negative y. And 0 minus 30 gets me negative 30. So now again, you can either switch the signs and just do y equals 30, or you can divide both sides by negative 1, however you like to think about that. No matter what, you get y equals 30. Now I have to plug that back into one of the equations. It doesn't matter which one. So say I pick the first one, I get 5x plus 30 equals 0. And I start solving. Subtract 30 from both sides. I get 5x equals negative 30. Divide both sides by 5, and x equals negative 6. And also this would be the ordered pair in which they're intersecting, so I can put negative 6, 30 as my final answer. And you can check your work to make sure this makes sense. I could plug in these x's and y's into the original bottom equation. I could plug it into any one, but say I want to plug it into the bottom equation. This is just for checking. If I take 5x, well, my answer for x was negative 6, so I'm going to put that in there, plus 2 times my y value we said was 30, and I'm going to see if it equals 30. I'm checking this bottom equation, and I'm just plugging in my x and y value. So 5 times negative 6 is negative 30, plus 2 times 30 is 60 equals 30, and when I calculate what's on the left, I get 30 equals 30. So I know that my answer is correct. I could also graph it and see that it's going to meet at negative 630. I would need a pretty big graph, or to number things a little bit differently on that one, though. Okay, and here is my third type of problem for solving by elimination. It's a big addition problem, remember. But I'm noticing that neither of these are going to cancel. If I look at my x's, they're not even close to canceling. I've got a 2 and a 3. That won't cancel. And the 4 and the 5 won't cancel. But in an ideal world, I can change these to whatever I want. So if I change the 2 to 6, like a common denominator almost, and the 3 to negative 6, then this would work. So to get the 2 to be 6x, I'd be multiplying everything by 3. So this one's 6x, I'm multiplying the whole first row by 3. This would become 12y, and negative 4 times 3 would be negative 12. And on the bottom, I'd be multiplying everything by, I want that to be a negative 6x, so I'm going to multiply everything by negative 2. So on the bottom, I get negative 6x, negative 2 times 5 is negative 10y, and negative 2 times negative 3 is positive 6. So now I've changed my x's to have, it would just be like a common denominator. I've found the least common multiple of the 2 and the 3. And I made sure that one of them was the opposite sign, 6x and negative 6x, so that they're opposites and cancel. For the y's, 12y and negative 10y would become 2y when I add them, and negative 12 plus 6 is negative 6. Then I divide both sides by 2, and I end up with y equals negative 3. Again, we can plug that into any of our equations. So say I take the first original equation, 2x plus 4y equals negative 4, and I plug in my y value of negative 3. So 2x plus 4 times negative 3 equals negative 4. Now I can solve for x. 2x minus 12 equals negative 4. Add 12 to both sides. 2x equals 8. Divide both sides by 2. X equals 4, and I'm going to write that as my ordered pair. 4 comma negative 3. Once again, we can check a couple ways. I can graph them, and see if they intersect at 4, negative 3. Or I can plug in a 4 and negative 3 into one of the original equations. So if I plug it into 2x plus 4y equals negative 4. So 2 times x, which is 4, plus 4 times negative 3 equals negative 4. 8 minus 12 equals negative 4. And that's true. 8 minus 12 is negative 4. So negative 4 equals negative 4. Sorry, you can barely see that, but I know that my answer is correct. So I was saying that you can check your work. So in order to check your work with graphing, you would have to isolate the y's first. So in this first equation, I would add x to both sides. And so I end up with y equals x plus 5. I have it in y equals mx plus b. So I can begin at 5, and I would rise 1, run 1, rise 1, run 1, etc. for my slope. That's my first equation. Let's change the colors here. Now I'm working with my second equation. X minus 5y equals negative 9. First I'd move x away from the negative 5y because I'm trying to isolate y. And so I get negative 5y equals negative x minus 9. I'm going to divide both sides by negative 5. And I get y equals negative divided by negative is positive. So that's actually 1/5 x. And negative 9 divided by negative 5 is positive 1 4/5, or 1.8. We're going to graph that for you. I'd begin at approximately 2, almost 2, like 1.8. And I'd go up 1 over 5. 1, 2, 3, 4, 5. And I can also do that the other way. I can go down 1 to the left 5. 1, 2, 3, 4, 5. And it's hard to tell. So if I draw my line here, I see that they're kind of going to intersect somewhere around here. So if I continue that pattern of the blue line, I was going off a little bit, as you can tell. I drew that poorly. You'll see right where the red and blue meet. Let me fix my blue line better now that I have it more accurate. Okay, so they're going to meet right at that ordered pair, negative 4, comma 1. That was the solution to our answer when we solved by elimination. So you can always check your work.